code base for my applications, focusing on state management, navigation architecture, and representations. Let's look at App 1, the Social Alchemist. The entire user interface is built natively using Jetpack Compose declarative UI tools. Looking at the main runtime block, state architecture is handled explicitly through the Compose runtime using Vimber and mutable set of hooks. Now, we are tracking 4 core states: select recipient, select situations, result text, and show info for our model dialog. These ones. To display our inputs cleanly, I implemented a lazy vertical grid. The lazy vertical grid, configuring a fixed column cell system. This passes the string arrays directly into a reusable composable component I authored called calculator button. This custom component dynamically switches its background color and text color depending on whether the boolean flag selected evaluates to true, providing immediate visual feedback. To respect the architectural principle of separation of concerns, the core processing logic is separated completely from the interface layers. Let's jump over to the social formulas.kt file. Here I established a dedicated Kotlin object acting as our computation engine. When the custom goal equal button is executed in the UI layer, it triggers the social formulas.calculate method. This one, passing or active states as arguments. The calculation relies on a structured multidimensional matrix handled via clean Kotlin when expression matching a combined state pair. It evaluates the recipient and situation tuple, matches it against our predefined hardcode string variables, and safely returns the optimized template back to the display handler. If the parameters are incomplete, a guard clause activates, safely returning an instructions prompt to prevent any application crashes. Moving on to App 2, Iron Ritual, the technical complexity increases with multi-page navigation and local data operations. Looking at the main entry layer, navigation is orchestrated via the Android X.Navigation Compose framework. I will demonstrate how the application handles mandatory data persistence to ensure that student profile modifications remain fully intact across device restarts. I integrated Android's native shared preferences API right here. Looking closely at these executions blocks in our settings configuration layout, you can see where our application code interfaces directly with the local storage files. We instantiate our persistence layer via context get shared preferences, and when an athlete updates their custom training profile moniker via the input field or toggles the automated rest time audio flag, the app opens a transaction lane using .edit right here. Yes, uses .edit. It then asynchronously serializes the primitive data types directly into the local device XML storage via .put string and also using the put boolean. If I force close the app from system memory and boot it back up, these preferences are safely read during the initial lifecycle sequence, preventing data loss. Finally, let's look at how a data consistency is achieved across different screens. This application utilizes state hoisting at the absolute apex of navigation ecosystem. As you can see by these declarations tracking our global athlete name and our current weight unit strings, the active states are held above the nav host graph layer rather than being localized inside individual screens, because these mutable states are hoisted high. Whenever a user updates their preferences, such as flipping the training metric from kg to pounds in the setting menu, the updated state instantly cascades down and forces a recomposition across the entire app. The text fields on both the lift deck checklist and the record worlds grid alter their layout text immediately and dynamically. Furthermore, to guarantee a total responsivity across differing phone hardware scales, all boundaries and text vectors rely strictly on density independent pixels and scale independent pixels. This completes my technical overview of the Iron Ritual framework as well. Thank you for listening.